Welcome to this special episode of the World of Engineering interview series. In this video, we discuss the Artemis program and recent updates with the Artemis II mission manager, and thank you to the community for submitting your questions to the Q&A. Now sit back and enjoy this 15-minute interview with the Artemis II mission manager, Matthew Ramsey.
Sir, I'm Matt Ramsey. I'm the Artemis II mission manager.
Before I jump into the questions, are you familiar with the Facebook group Space Hipsters?
No, I'm not.
Okay, so they're a big group of space geeks, about 60,000 members. Oh. And the reason I bring that up is they actually provided a lot of the questions we're going to be asking today.
Good, okay.
First question comes from Chris Bovino, and his question is, what is the status of the Artemis heat shield investigation from Artemis 1, and how does that impact Artemis 2?
Yeah, that's a good question. So the heat shield, we had spallation on the Artemis 1 heat shield. We have had a Tiger team working that since we landed, and we're able to do a visual inspection of the heat shield. That work is concluding. I'm not going to get out ahead of the decision that's about to be made for Artemis 2, but they've been doing a lot of wind tunnel testing at the ArcJet, at Ames, a lot of other wind tunnel testing to try to characterize what the root cause of the problem was. I think that they are in pretty good shape on understanding what the root cause of the problem is. Again, I won't get in front of them talking next week to the program control board, but I think they have a pretty good handle on root cause, and they will make a recommendation to the program next week on use as is or remove and replace.
Well, Chris, it looks like we're going to have an answer soon.
Yeah. Sorry.
This next question comes from Jeffrey Forney. Will any science experiments take place outside of the vehicle itself during Artemis 2?
Let's see. So on Orion, no. We are planning on having 5 secondary payloads that will be deployed from the Orion spacecraft adapter, which is the adapter in between Orion and the ICPS, or the second stage that we use. Those will be deployed after we do the proximity demo, ProxOps demo. Orion will separate and use ICPS as a target to determine handling qualities. After that demo is complete, we will dispense the 5 secondary payloads. So those are they're all international partners that we're partnering with for Artemis 2 for those secondary payloads. Can't say yet who they are. They have to get through framework agreements or implementation agreements, and then phase safety reviews. But we're looking forward to working with them. So that science will be done. Each one of those secondary payloads has different science that they're doing. Some of it's Earth observing. Some of it is space weather. Some of those types of payloads. So yes, we will do some science, not outside of Orion as we're going to the moon, but in high Earth orbit.
Obviously, you can't commit to any firm dates, but is there kind of a rough estimated timeline of when we'll find out what the final science experiments chosen will be?
I would say in the fall we'll know. I hate to give you a fuzzy answer like that, but the fall of this year. So the payloads will have to show up in February, March of next year. So the partners that we have are continuing to work. The development is just getting the I's dotted and T's crossed with the State Department, and these are international partners. So to share data, we have to have pretty formal agreements with them. So I'd say fall. Fall is a pretty good answer.
Fall.
Yeah.
So the thing with space exploration is if somebody isn't giving you fuzzy timelines, they're probably not being truthful, because when you're pushing the limits and expanding and pushing the edge of the envelope, there will be a thing called known unknowns and unknown unknowns. There's a lot of unknown unknowns as they're rolling into Artemis 2. A lot was learned from Artemis 1, but there's still new learning lessons from Artemis 2. And the further away you are from something being completed, the harder it is to be accurate on the timeline. That is just how it works in the world of engineering.
Well said.
This next question comes from Dan Fisher. Will the spacecraft itself carry as many external cameras as Artemis 1, and will the crew be able to use any handheld cameras to provide additional perspective to the viewers?
Yeah, we'll still have the solar array wing cameras. I don't know if there are any other external cameras. The crew will have handheld cameras that they will use and do, their activities. They'll record some of their activities, that they have to, the jobs that they have to do while they're on the, exercising, checking out the systems. They'll be recording all of that. So there is a Nat Geo experiment that will be flown on Orion that the crew will be using their hardware to record live images and videos and that sort of thing that they'll then take afterwards and post-process that. But I think there are also other, there are cameras inside Orion. You saw them for Artemis 1. I think there are more for Artemis 2 and looking at different things. So yeah, we'll have good video coverage, and we've worked on upgrading the downlink system to be able to get video out to outlets faster than we did for Artemis 1. So
fantastic. One of the best ways to get people excited about space is to let them see what's happening real time and go, whoa, we really did that.
Yeah, and you'll have all the crew. You have the crew piece that you didn't have for Artemis 1, and that's always exciting, in my opinion, for the public to be able to see that, what they're doing, what jobs that they're required to do, what science we're doing on board, and what other requirements that they're trying to meet while they're headed out to the moon and back from the moon.
And there's something special about crewed missions. By seeing that those astronauts there, representing the population that they come from, people can see themselves in those heroes going to the moon. So it's very exciting to see we're stepping back into manned space flight, returning to the moon, and eventually beyond.
And the Canadians are going with us. So that's that's another kind of wrinkle that's different than Apollo. Is we're bringing in international partners. I mentioned the secondary payloads that we have for Artemis 2, but we also, Jeremy has been involved from when the crew was named. It wasn't a U.S. crew and a Canadian crew. It was the Artemis 2 crew. So I was very excited to see that. And as we continue on, there are other international partners for, say, Gateway that we already have on board that are working Gateway now, that for Artemis 4 we'll have them in position and contributing. So the International Habitation Module that we'll be taking out to the initial capability Gateway is an ESA built hab. So yeah, a lot of good collaboration going on there.
So let's talk a little more in depth about the international partners. We have ESA, we have Canada, we have Japan. Can you talk about some of the actual technologies that they are working on and contributing to the broader Artemis missions?
I can. So from a JAXA perspective, they are building the pressurized rover for us. That won't be, I don't know exactly what flight that's going on, but it won't be before Artemis 4. I do know that there's an Esprit module. So the Gateway has a lot of international partnerships. There's a Canada arm for the station, or for the Gateway station. I mentioned the ESA is building the iHab. I forget who's building the Esprit module, but it's also an international partner. JAXA is also building some of the ECLSS systems for Gateway, so environmental control and life support systems. So there's a lot of international agreements in place and a lot of work that's going on. And of course, the ESA builds the service module for Orion. So that's another huge, that's an integral in everything that we do. The service module is integral in everything that we do for missions for Artemis.
How much design, development, and engineering collaboration is there between NASA engineers and the International Space Agency partners? And is there different pieces of it that is requiring a lot more NASA involvement than others, or how is that going?
Well, I think that they are responsible for meeting the design requirements, they being the international partners. Now, NASA does have an insight into how they're performing against that, and I believe that the international partners have to provide verification data back to say these were the design requirements. Here's our design, and here's how our design is meeting those requirements. So that is to me, that's probably the biggest way that the NASA team and the international partner teams interact is through requirements determination and verification of those requirements. So that's a big piece of that. They're also involved in the mission design phase. So you've got the design requirements that are sitting out here in spec space that are then verified, but then, that establishes a pretty big box. A particular mission might fly a point in that box. So if the point in the box is outside the box, then you bring the international partners in to say, hey, we think we need to operate maybe your hardware a little bit outside of the box that we gave you. Are you okay to operate there? Or if it's right in the middle of the box, then the international partners have the opportunity to say, hey, it's within our design certification, we're good. So that, I would say that's a big part of how we deal with our international partners that are responsible for designing elements.
Let's talk now about commercial partners. SpaceX, Starship in particular, is going to be playing a big role in Artemis. What's your take on the current development progress of Starship down in Brownsville? We just had ST4. I believe they're preparing for ST5 now. How do you feel about the progress in meeting the Artemis mission time, like objective timelines?
Yeah, I mean it's hard to argue with progress, right? I mean, you saw, I don't know if it was IFT, OFT 1, 2, 3, 4, or whatever, and it's clear that they're making progress. They have some technologies ahead of them that they have to prove out. The flights that we're seeing now are testing the airframe and the propulsion systems and the types of stuff that we did for Artemis 1. We shook the launcher out, we shook the spacecraft out, and they're in the middle of that right now. We are asking them to do a lot more than that. We're asking them to land on the lunar surface. And their ConOps is such that they have to do in-space refueling. That's never been done at that scale before. I feel pretty confident that we'll get there. That SpaceX will do a good job there. Blue Origin is also a lander contractor. They don't have the same ConOps. It's still a refueling type ConOps in space. That is to me one of the biggest hurdles that we have going forward is that in space refueling. So that's supposed to happen next year, and we'll see how that goes. I don't really have any knowledge on when exactly that's supposed to happen, but I believe it's next year. So we'll see the first attempt at a in-space transfer of propellant next year.
Orbital refueling is going to be a fun milestone in the moment of space exploration.
But it's science fiction-y. I mean, it's like, oh, well, this is a pretty cool deal. Them putting that into practice is going to be game-changing.
I mean, I thought it was cool enough as a kid watching footage of the B-2 bomber getting refueled mid-flight. Now we're going to be doing it from orbit. These shots are going to be stunning.
2 skyscrapers transferring propellant.
Yeah, right. Yeah. Exactly. Stainless steel on top of it.
That's right.
I mean, obviously it's got heat shield tiles, so we're not going to get to see its reflectiveness, but still, it's pretty cool.
That is going to be that's a big deal. That's a big deal for NASA and Artemis.
Any final thoughts about the Artemis program? Any insights you'd like to share with the space hipsters and or the world of engineering?
Yeah, I'll talk mainly about Artemis 2. I'm also the Artemis 4 mission manager, but Artemis 2 is the alligator that's closest to us. Having the crew on, there's an alligator there. Having the crew on board is really, I won't say it's changed our thought process, but it has modified the way we think about accepting risk, because you're not just accepting risk for the hardware anymore. You're accepting risk for the crew themselves. I know the crew, they're awesome people. They have families. The families are counting on you to make a good decision for their family, and that's not something we haven't had to do that on Artemis. It's been a while from my perspective that we've had to do it for human space flight, but I know the Crew Dragon, I haven't been a part of that, but I know that they have to take that into account when they're making decisions there on risks affecting missions. So that's would be my biggest takeaway is we're having to change our thought process on how we accept risk for missions and for the crew. So they do have a say. They have representatives that when we make these decisions, like on the heat shield next week, the crew will be they will be apprised of where we are, and they will have a say in which direction we go based on whatever, the team recommends. So that is one of the bigger takeaways I'd like for you to push out to folks is, we're getting to the point now where we're making human-based risk decisions. So that's another level of complexity.
Well, sir, thank you for your time, and Godspeed on the Artemis II and the future Artemis 4 missions.
Great. Thank you. It's good talking with you.
Thank you. I hope you guys enjoyed this interview. And for future interviews, if you want to give us your questions as input, follow our page on X at Engineers Feed, and stay tuned for our post asking for topic-specific input questions. Thank you so much for watching, and we'll see you next time.